Hi there and welcome to tutorial 20 on the normal distribution, and this is for the Edexcel S1 A-level module. Now, as always, it is applicable to most other exam boards, and if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Now, in previous videos we've been looking at discrete random variables and finding their associated probabilities. Now what we're going to look at in the next few videos is all about finding probabilities for continuous random variables, and one of the most commonly used distributions is called a normal distribution. So let's talk about some of the properties of a normal distribution. A normal distribution is generally a bell-shaped curve such as this. What we say is that the standard normal has a mean of mu, that's the Greek letter mu, and a variance sigma squared. Now with the standard normal, the mean is 0 and the standard deviation is 1. So this is just saying that z is a random variable that is distributed normally with a mean of 0 and a variance of 1 squared, or a standard deviation of 1 if you like. Now let's just talk about some of the various properties of the normal distribution. One thing to note that's very important is it has a mean mu and standard deviation sigma. Another thing that's crucially important is that it's symmetric with a total area under the curve equal to 1. So the total area underneath the whole curve is equal to 1, and it's symmetric about its mean. So in this diagram I have here, that's my mean, mu, which is actually 0. Further things to note, it has a single peak at its center, which is up here. It is continuous and infinite in both directions. So this is what we use to model our continuous random variables, and it's infinite in both directions. It doesn't actually stop here. We'll get infinitely closer to the z-axis in this case, but we'll never actually touch it. And what we'll find is actually that 95% of the values will actually lie within 2 standard deviations of the mean. So this is 2 standard deviations below the mean, that's 2 standard deviations above the mean, and you'll find that 95% of the values are actually located within here. Another thing that's important is that we'll find that 99% of the values actually lie within 3 standard deviations of the mean. So 99% of the values are actually right within this area here. Now the normal distribution has a set of tables to go with it, the normal tables. So I'm just going to discuss how we can find probabilities using the normal tables. So suppose I was asked what the probability is that my random variable is less than a particular value z, sometimes written as this phi of z. So suppose z was here, that's my value z, little z, and I wanted the probability that it's below that value. So I'm basically looking for the total area below that value, and it sometimes can be written as phi of z. The tables look a little bit like this. So they are my particular values of z, and also notice that they're all positive. So if I was looking for something like the probability that z was less than minus 0.01, I will have to start using symmetry to help me get the answers to this. Also with the normal distribution, it's worth noting that because the total area under the whole curve is equal to 1, that means that half of the probabilities are down here. So the total area must be 0.5 on that side, and the total area down here is also 0.5, and that's going to be useful a little bit later on as well to answer some questions. So if I was asked to work out, let's actually take a look at an example here. So absolutely crucial to this topic is that you sketch a diagram. Whenever you're asked to find probabilities, you always sketch a diagram. It will make your life so much easier. So suppose I was asked to find the probability that Z is less than 1.15. So I have my diagram sketched, and essentially what I want to know is what's the probability that Z is less than 1.15. So 1.15 is there. So what I'm trying to work out is the area to the left of this line, because it's less than 1.15. So what I do is I go to my table and I look up where Z is 1.15, and we can see here that the answer is going to be 0.8749. So that equals 0.8749. This question could have been given like this as well. It could have been asked to find phi of 1.15. These two are interchangeable, they mean the same thing. So the answer is 0.8749. Let's take a look at another example. I'm asked to find the probability that Z is greater than 1.63. So again, I know that this is 0 here. 1.63 is going to be somewhere there, so I'll just mark that in, 1.63, and I want the probability that Z is greater than 1.63. So what I'm actually interested in is this area here. Now my tables actually only tell me what the probability of Z less than a particular value is. So I need to use symmetry. Sorry, not symmetry, I need to use the fact that the total area under the curve is 1. So if I can work out what the probability that Z is less than 1.63, so that's what I'm going to work out. I'm going to work out the probability that Z is less than 1.63, and then if I subtract that from 1, I get my answer here for this area. So I'm going to work out this, and I'm going to subtract it from 1. So it will be 1 minus, let's go back to our tables, 1.63, which is over here, 0.9484. So 0.9484. Okay, so let's bring up the calculator now and do 1 minus 0.9484 gives me 0.0516. 0.516. Just something else that I remember to pass on is that you shouldn't round to 3 significant figures when you're dealing with normal distribution. Try and keep your answers exact right the way through the question. Let's go on and look at the next part. Suppose I want the probability that Z is less than minus 0.54. So again, remembering this here is 0. So I want minus 0.54, which is going to be somewhere over here. So we sketch my diagram, minus 0.54. And I want the probability that Z is less than that value. So I'm interested in this area here. But we have a little bit of a problem, and that's the fact that my normal tables actually start from 0. They only give positive values. So here's an opportunity to actually use the symmetry of the curve. So if I bring this down here, if I have a look at the probability of Z being less than 0.54, not minus 0.54, let's have a look at 0.54, which would be over here. So if this is 0.54, I can get the probability that it's less than 0.54 quite easily from the table. And the part that I'm interested in is actually this blue bit over here, because this blue area is actually going to be the exact same as this blue area because it's symmetric. So I'm going to do, if I work out the probability that z is less than 0.54 and then subtract it away from 1, it leaves me with the blue bit here. So I'm actually going to do 1 minus the probability that z is less than 0.54. So let's return to our tables. It's going to be 1 minus 0.54 is here, which is 0.7054. 0.7054. So let's take out the calculator. 1 minus 0.7054 gives me 0.2946. So the symmetry of the normal distribution is really, really important to help us answering questions. What about something like this? Suppose I'm asked to find the probability that minus 1.11 is less than z, which is less than 2.14. So let's just kind of sketch out what this is going to look like. That's roughly around minus 0.11. 1.11, 2.14. I can just sketch and say it's there. So 2.14. So I'm interested in the area trapped in here. Now this can be a tricky one to do. Well, if I worked out the probability that z is less than 2.14, let's bring out another one here. So if I have this 2.14, I can work out the probability that z is less than 2.14, which will give me this total blue area here. There's a section of it I'm not interested in. I don't want this piece here. I need to take this piece away. So again, we're going to use the symmetry of the graph and the symmetry of the curve, should I say. So I won't be able to work out 1.11 and minus 1.11, but I will be able to work out positive 1.11. So that's 1.11 there, and I can work that probability out. And what I can do is I can actually take that probability away from 1 to get this green piece here. And that green piece is actually going to be the same. It'll have the same area as that blank space there. I can take that away from this, which will leave me with this probability here. So let's work our way through it. Let's work out the probability. Let's work out this green piece here. So I'm going to do the probability of z being less than 1.11. And I'm going to take it away from 1. So I'm going to do 1 minus the probability that z is less than 1.11. So let's go back to my table. 1.11 is here, which is 0.8665. 1 minus 0.8665. 0.8665 gives me 0.1335. 1, 3, 3, 5. Now I'm going to take this value away from this area here. So let's work out the probability that Z is less than 2.14. Let's go back to our tables. 2.14 is here, so that's going to be 0.9838. 9838. So this probability here represents that total blue area. The green probability represents that green area, and if I subtract the green area away from the blue area, I get left with this smaller blue area here. So I'm going to subtract 0.1335 0.8503 gives us the answer. Okay, time for you to have a go now. So pause the video and see if you can work out the solutions to these. Okay, hopefully you've had a go at that. There are your solutions there. Okay, let's move on and have a look at finding a particular value of A when given the probability. So I'm given the probability that Z is less than A is equal to 0.7611. Remember, the total area under the curve is equal to 1. So 0.76 will be somewhere around here. So I'm looking for A. I know that this area in here is 0.7611. So what I'm going to do is I'm actually going to go to my table and I'm going to look for 0.7611. And if we see it here, 0.7611 has a probability of has a value of 0.71. So A must be 0.71. Probability that Z is less than 0.71 equals 0.7611. Let's have a look at another example. Suppose I want the probability that Z is greater than A, or I'm told the probability that Z greater than A is equal to 0.01. So probability that Z is greater than A is 0.01. So let's call it that area in here, 0.01. So that must be A. So I know that the total area trapped in this section is 0.01. So this is actually a moment where we need to use what's called the percentage points table, which tells me some particular values when Z is greater than little z. Now 0.01 can be seen here. The probability of 0.01 is that. So that means the value of Z is 2.3263. It must be 2.3263. Okay, let's move on and have a look at the next example. Now, I want the probability when Z greater than A is equal to 0.0287. Sorry, I'm not looking for the probability, I'm looking for the particular value of A that gives me a probability of 0.0287. So, about 2% probability. So I'm looking for, I know that this is 0.0287 and that's my particular value A. Now if I go to my table, there's nothing here that represents 0.0287, and if I look at my normal distribution table here, I can also see that the probabilities start at 0.5. So it's actually less, it must be less than 0. It is less than 0.5 in the question. So I'm going to have to use the symmetry again. if that is 0.0287, then I can work out what everything here is. So, if I do 1 minus 0.0287, that gives me 0.9713. So I know that this section here is 0.9713. Now I will be able to use my tables to find this out because the probability is greater than 0.5. Let's go back to our table. The value is 0.9713. So let's have a look and see if I can find the value for 0.9713. There it is, 0.9713. The value must be 1.9. So A must have a value of 1.9. So 1.9, 0713, yeah, 1.90. 1.90. Because the probability that Z is less than 1.990 is equal to 0.9713. Okay, let's have a look at the next question. So, example 8, what about the probability that Z is less than A equals 0.0170? So, I'm told that the probability here is less than 1%. Now, if I know that the bottom half represents 50% or 0.5 of the total probability, and this represents 0.5 of the total probability, well, 1%, the first 1 or 2% must be down here somewhere. So we're actually looking for a negative answer. So my value A is going to be here, and I want to work out its probability. So, because our tables don't actually give negative probabilities, I'm going to have to use symmetry again. So, what I could look at is imagining A is here, and I know that that would be 0.010170. That's the area in there. And then what I can do is I can subtract that from 1 to get this area here. So let's do 1 minus 0.0170, and we get 0.983. 0.983. So this blue area in here, 0.983. Okay, let's see if we can find a value in our tables that has a probability of 0.983. So let's have a scan through. 0.983. 0.9830 has a particular value of 2.12. Has a particular value of 2.12. 2.12. But if we do remember correctly, at the start of the question, I was interested in A, which is over here. Let's call that other A. Let's call it A dash. That was my original position of A. So if that's 2.12, and because it's symmetric, this must be minus 2.12. So A equals minus 2.12. Okay, let's keep going. Example 9. What about the probability that 0 less than Z less than A equals this here? And I'm asked to work out this probability. So, I know that the area is 0.3554. So, and I know that the top half is 0.5. So, if I suggest that A is here, and this must be 0, I want the area, I know that the area trapped in here has a value of 0.3554. Okay, now I won't be able to work this out straight away, but I do know that if I add on 0.5 to this, it will give me the total area to the left of A. So if I add on 0.5, let's add on 0.5, I get 0.8554. So now this total, the red and the blue over here, this total area in here has a probability of 0.55 or 8554. So let's return to our tables. 0.8554, which is here. 0.8554 is 1.06. So A must equal 1.06. Okay, let's keep going. What about, I'm told that the probability of minus A less than Z less than A equals 0.5820. So we're going to have two values, A and minus A. And I know that one must be to the left of the 0, one must be to the right of the 0, because one is positive and one is negative. So let's call that A, call that minus A there. And I know that the area trapped between these two lines is 0.5820. Now, because I know that to the left of the 0 and to the right of the 0 it's symmetric, that means that they each have half of this area. So they each have half of this total area. So I can work out, let's get a blue pen, I can work out the probability between 0 and A quite easily by halving this area here. So if I take 0.5820 and divide that in half, I get 0.291. So this particular section in here has an area of 0.291, and I also know that everything to the left of the 0, total area to the left of the 0, has an area of 0.5. Now if I add this area onto the blue area, that gives me everything to the left of A. So I'm going to add on 0.5 to 0.291, which gives me 0.791. So I know that the probability that my random variable is less than A equals 0.791. So then I go to my table. The probability is 0.791. So let's see if we can find 0.791. 0.7910 gives me 0.81. 0.81. So A must equal 0.81. And you could always work backwards again to check your answers. You could put 0.81 there, minus 0.81 there, see if you can get the total probability for that section and see if it comes out to be 0.5820. Okay, on we go. Okay, so next one here is the probability that 0 less than Z less than A equals 0.10. So let's draw that in. If I call that A there, and I know that this area in here is 10% or 0.1. I can add on, like we've done before, add on 0.5, and I now know that the total area here is 0.6. So I can safely say that the probability that my random variable is less than A equals 0.6. I can go to my table now and have a look. Is there anything that has a probability of 0.6? No, I've got two things that are in between. So maybe I actually need to use my percentage points table, which is the probability that z is greater than little z. Right, so let's go back to the question. I know that the probability that z is less than a equals 0.6, so I can safely say that the probability that z is greater than a equals 0.4. So this area here must be 0.4. So can we use the percentage points table? Have I got a value for 0.4? Indeed I do. It's 0.2533. So a must be equal to 0.2533. And you'll notice that 0.2533 should be somewhere between this one 0.06, which is what we were looking at earlier, and 0.59. 0.2533 is somewhere in there. We're actually getting a more accurate answer. Okay, one more example to go. What about minus a less than z less than a is 0.80. So again, let's draw our diagram. Call that a, call that minus a, and I know that the total area chopped between those two lines is 80%, or 0.8. The total area is 0.8. And we're going to have to use the fact that, well, if that's 0.80, and it is symmetric about 0, that means that I know this blue area, which I'll shade in here, must be 0.4. So that's 0.4 inside there. And then what I can do is I can actually remove the fact that we have negative a. I can eliminate that. And I can introduce, I know that this area here to the right is 0.5. So the green area is 0.5. I can add the green area to the blue area, which tells me that the total area to the left of a, that z is less than a, is going to be 0.9. So that's 0.9. Which means that the probability that z is greater than a equals 0.1. So I know that this area in here is 0.1, and if we go back to our table, have I got anything in my percentage points? I do. 0.1 here, which is 1.2816. 1.2816. So a must be equal to 1.2816. And that's it for now. Okay, hopefully now you've got an idea of how you can use the tables, symmetry, and the various properties of the normal distribution to solve these problems. You should now be able to do exercise 9a and 9b. That's it for now. I'll be back again with a new video soon, so best of luck with revision, and I'll talk to you again sometime.